Okay, so let's discuss really quickly what it means to be parallel and perpendicular. So if you remember from before, parallel lines are two lines that never touch. And that's a very English way of describing what it means to be parallel. Right? So the way that you describe it is probably just that they never touch, something like that. And it's parallel. But remember, this is a math class, right? So we need a formal math definition which will coincide with this English definition. Now, I know the English part is easy and very straightforward to see, but the math one is the one that you actually need because you need to be able to look at an equation and then determine whether or not lines are parallel. And so the math version, I'll write this as the English version. The math version is going to say that two lines are parallel if one, the slopes are the same, and two, their vertical intercept is different. Now, this right here is equivalent to saying the B's are different. Now, I hope what you could do is you could see why these things are true based on the English definition, right? If the lines never touch, well, they look like this. And slopes, remember, are how fast lines are going up or they're going down. So if they never touch, don't they need to go up at the same rate or down at the same rate as well? So this should be very clear just by looking at this, as should this one. Because if I drew an axis now, like that, well, if they're going up at the same rate, they will touch the axis at different points. If they did not, if they touch the axis at the same point, they would look like that, right? You'd have two lines which are lying right on top of each other. And that is not parallel even by the English definition, right? They do not touch because they touch everywhere. So this is something that is going to be very important when you use systems of linears because it'll explain to you what it's actually doing. Now, the other version, right, we said is the perpendicular one. So perpendicular So the English version of this is going to be they intersect at a single point and then they make the 90-degree angles. Right? So they form these 90-degree angles. Now, that is very useful if you could see it visually. But if I actually drew a graph, something like this, do you know offhand that those angles are 90 degrees? Or are they 91 degrees or 89 degrees? It's unclear. So what we need to do is have a more formal math definition that we can use so that we can actually determine whether or not these things are perpendicular or not. So the formal definition, which is the math version, is two lines are perpendicular if their slopes are negative reciprocals. Of each other. So what that means is if you have a slope a over b, the other one must be negative b over a. And so if you want a less math-intensive definition, they're negative flips of each other. Okay? So flip the fraction and put a negative in front. So this is how you determine if two lines are perpendicular. You only need to check this one thing. Now, what I'm going to do is I'm just going to make up a couple of equations, and you determine parallel, perpendicular, and the third choice is neither. Because you can have two lines where it is neither perpendicular nor parallel. And this is an example if this was, let's say, 87 degrees. Right? They touch at a single point, but the angles that they form are not 90. So let's go ahead and just do a couple of examples and determine whether or not they are perpendicular or parallel, or neither. So let's say 3x plus 2y equals 1, and then 2y is equal to 1 plus 3x. How about y is equal to pi x plus 1, and then y is equal to negative 1 over pi x plus 1, or plus 3. And then the last one, let's say y is equal to 3 over 7x plus 5, and then negative 7y is equal to negative 3x minus 6. Okay. So let's look at all of these, right? And in order to test whether or not the lines are parallel or perpendicular, go through the list. If it fails to be parallel and then it fails to be perpendicular, then it ends up being neither. So it's easiest to do, right, if we solve for y first, because that's how we are able to see slope very fast. So here, right, 2y is equal to 1 minus 3x, or y is equal to negative x plus, sorry, that's a 2. Negative 3 over 2x. So this whole thing is that one. The next one is going to be y is equal to 3 over 2x plus a half. So this one, dividing both sides by 2 gives you 3 over 2. Divide that 1 by 2, you get a half. So let's write the one on the top underneath, which is y is equal to negative 3 over 2x plus a half. And ask yourself the questions that we need to determine if it's parallel. Are the slopes the same? Well, one is negative, so that's a clear no. Once it fails one of the tests, it's automatically not parallel. Perpendicular. Are the slopes negative reciprocals or negative flips of each other? Well, they're negatives of each other, but they're not flipped. So this is not perpendicular either. So this one right here is neither. Okay. Let's look at the next one, and can we see that it's already in slope-intercept form, which is really nice, and we already know the slopes. Just because it happens to be a pi doesn't matter. Okay? So the slope here is pi, the other slope is negative 1 over pi. So are the slopes the same? Again, the answer is no, so it's not parallel. But can we see that this is actually pi over 1? And if I were to flip it and then put a negative in front of it, you get that one, which is the second one. So since they're negative reciprocals of each other, these two lines are perpendicular. Now lastly, we don't have this solved for y yet, so let's go ahead and do that. Y is equal to 3 over 7x plus 6 over 7. And now look, are the slopes the same? Yes, they're both 3 over 7. And is the b value, or the vertical intercept, different? The answer again is yes. So this one is parallel. These problems will be very straightforward unless you have to solve for this y first. But in general, remember the things that you need to look for, which is the math definition. Parallel, slopes are the same, different intercept. Perpendicular, slopes are negative reciprocals of each other, or negative flips. And if it fails both of them, then they are neither parallel nor perpendicular.